Hey Algebra students, this is your notes for 4.9 and my document camera seems to be working. It's froze up on me once, or twice already, so I'm hoping it works, but that's why you're going to see some things written out already. Okay, so we're talking about absolute value here today, and it's going to be 4.9. We've got one word to know, which is absolute value. So we're going to start with just the absolute value of 3. When we have the absolute value of 3, we know that it's 3 because it's 3 away from 0. When we have the absolute value of a negative 5, we know that it's 5 because it's 5 away from 0. But if we have the absolute value of x, that means that we don't know what x is. It's a variable, right? So we could have a couple of options here. So if I talk about x away from 0, that x could be over here because the distance from here to here is an x. Or it could also be negative because the distance from here to here is x. So it could be an x or it could be a negative x. So as you guys see this and as you guys start thinking about this, know that it could be 2. Now if you need to pause the video because my notes are faster than probably what you wrote, go ahead and do that. But we're going to start looking at a couple examples here as well. Okay, so let's take a look at what this graph of an absolute value looks like, because that's also pretty cool. So here we go. So if we have the absolute value of x, and I want to say that is going to equal y. Okay, so we've got our in, which is our x, and our out, which is our y. Okay, so if I make a box, here's my in, here's my out, or if I like to do x's and my y's. So let's see what happens here. If I put a negative 3 in, the absolute value of negative 3 would then be positive 3. If I put a negative 2 in, the absolute value would be a positive. 0 then would be 0. 1, you got it, 1. And 2 would be 2. Perfect. So if I come over here to my lines and I graph, and you guys are hopefully on graph paper so you guys can make a beautiful graph here. If I'm at negative 3, 1, 2, 3, I go up 3, 1, 2, 3. If I'm at negative 2, it's going to be 2. If I'm at 0, it's 0. If I'm at 1, and then 2 is 2. And so what happens is if I take like decimals and all my other whole numbers into consideration and I think about how this graph looks, what happens is this graph looks like a giant V. And it pops off right at that 0. Like it's like a giant V coming off. And this is how all absolute value graphs look. And it's really sweet because it's a totally different graph than what our linear graphs are. It has a bend in it, and you can make some really cool things. Okay, so we've got absolute value. We know a little bit about graphs here. So now what we're going to do is we've got to figure out how to solve these. Like what happens when we have an example. So let's try a topic. And the first one is solve absolute value. Actually going to take a look at it and see what we can do to solve these problems. So we're going to start with this first one. We're going to do the absolute value of 6 minus 2x, and we're going to set it equal to 18. And we're going to go through a couple different ways here. Okay, so do you guys remember on this first page when I was talking about the absolute value of x, it could be either x or it could be negative x, right? Like that's the solution. So when we see this, of 6 minus 2, or 2 x's, it could be like the inside of this. The answer to this is going to be 18. Well, this then could be a negative 18, and I would get the absolute value of 18 would be 18, or it could be a positive 18, and the absolute value of 18 would be 18. So if you need to rewatch this part, please do so, because this is the most important part, and this is the biggest thing for you guys to understand. So really when we do this, we have to take our absolute value and we're solving the same equation, but we're solving it for 2 different values. So we're going to say, well, 6 minus 2x could equal positive 18, and we could have 6 minus 2x equals a negative 18. Because that absolute value could be 18 or negative 18 to get 18, then you have to use it twice. You've got to solve for it twice. Alright, so if we just start solving this equation, set my monorail or railroad track, whatever you guys want to do, we're going to subtract 6 from both sides, negative 2x, and what do we get here? I'll let you guys figure that one out. See if you can go all the way down with x before I start filling it in. Or pause the video and see if you can do it. You should get a 12 divided by negative 2. Hopefully you got an x is a negative 6, question mark, hopefully. So that's one of our problems. The other problem, if I subtract 6 on both sides, okay, what do we get? Negative 24 and a negative 2x. Don't forget that term. It's a negative term up there. So now we have divided by negative 2, and we get x equals 12, hopefully, if you solve those correctly. So we have these two answers. So x could be a negative 6. So if we go back up here and kind of think about this x right here could be a negative 6. And if I put in negative 6, I should get a positive 18, and the absolute value of positive 18 is 18. And if I put in 12 here for x, 12 times and that negative 2, adding the 6 in, take the absolute value, I should get a negative 18. And the negative 18, absolute value of that will equal 18. So both of these answers are going to be the same, or is going to work for this problem, which is awesome. Okay, so let's think about this on a graph. As I start to graph this, what happens is my graph at 18, so I'm just going to imagine this at 18. And if you guys want to put this into Desmos after like I try this with you. Oh no, I froze again. Okay, so I just froze, but I think I fixed it. I don't know, we'll see. So sorry about the weird lapse in this connection. So I had 18 up here. As I was talking, I noticed that this got froze. But you can put this into decimals, like I said. You can say y equals, or the absolute value of 6 minus 2x. And what happens is it hits right at 3 for our like check mark, or it hits like right in there. So if it comes up like this, our 18 line, where y equals 18, is going to be 2 points. So that's where those two answers come in. And it froze again. Okay, hold on. So I hope it works this time. Okay, so as you guys can see, there's these two answers that you couldn't see before. So this 18 crosses the line at 2 points. Okay, I'm really scared to continue, but we'll see. The second part of this is going to be with inequalities. So with inequalities, hopefully my screen doesn't die again. For inequalities, if we have something like, so this would be topic number 2. For example, 8x plus 24 absolute value is less than or equal to 40. So in fear of having this freeze, if it does, I'm just going to show you guys the solution. But how it works, again, is we need to say, okay, so this part in here can be 40, or it can also be a negative 40. But because we have this inequality, we have two different things that we can do with this. So what we're going to rewrite this as is a negative 40 is less than or equal to 8x plus 24 is less than or equal to 40. So that double inequality now allows me to solve for both the negative and the positive side of this inequality. So I'm hoping this won't die on me, and I might just have some help here from students who are walking in. So if I put in my railroad tracks, I solve it just like everything else. If I subtract 24 on all three pieces. So on the left, can you figure out what that's going to be? And my answer? Oh, he's still looking. 64. And then this one over here is going to be, what's a 40 minus a 24? Can you get it? Take off the 20, and then we're down at 16. So we're at positive 16. So now I've got 8 x's, and this is still going to be less than or equal to, because we haven't divided or multiplied by a negative. So now we divide everything by 8 to get 1x by itself, and students are coming in. So this side we're going to have a negative 8 is less than or equal to x is less than or equal to a 2, and that's going to be my answer. It creates a double inequality when we solve for absolute values. We're going to go over a few more examples as we go through class next time, but get those in your notes, and we'll talk more when I see you on Wednesday. Bye!